Now here, as I told you that we have to perform different operations, either memory read, memory write. So the previous lecture I have given you the details about this opcode fetch. So now here we are going to talk about these memory read operations. So in these memory read operations, it is also a kind of instructions where these kind of instructions to move a comma m, move c comma m, move r comma m. That means m means always stands for memory, and memory, m basically denotes the HL register pair location. HL register pair when we are going to do pair because of it holds suppose 2050H memory location. So in this memory location some content will be there, so that content will be treated as a m. So the content of memory locations, I can say this is m, means the memory locations. So move a comma m means the content of memory locations will be moved to accumulator, copied to accumulator. Move c comma m, the content of memory locations, the specified memory location, suppose HL register pair. Memory location means HL memory register, HL register pair locations will be copied to the C register. So basically we can write move r comma m. Any r means register. So any register you can take. So the content of m means the content of these HL register pair locations holded by the HL register pair locations will move to the content of HL register pair locations will move to register, particular register. Here also I told you the same thing, that it is also one machine cycle is needed, and 3 it requires 3 T state, T1, T2, T3. Just like earlier the opcode fetch was there. So the opcode fetch requires 4 T state, but this is needed as 3 T state. 3 T states required. Right. So again the similar fashion we have taken T1, T2, T3, these are the T state. So you can say the memory read machine cycle. Okay, here we can write memory read. It operations machine cycle. I hope it is visible to all of to you. Now coming to this part, again the same fashion we are taking 8 to a15. So 8 to a15 means this is the higher order address bus. So higher order address byte will be taken. Now again if I talk about this, it is supposed started from 0500 or say 1000H memory location. You know how the thing is going on? Always we have to give the starting memory location to the PC, means program counter. Whenever we'll give the PC means program counter, so first we have to place the starting location to the program counter and they will start, then it will be going to start, right? So 1008 suppose the starting memory location, so move a command, this is also 1 byte instruction, so only uh, this whenever we are going to do such kind of memory read operations, so for this memory read operations what we are going to do, the things we have to take from this memory, right? So for these things, suppose 1008 we have to take these memory locations. So in these memory locations, this is my higher address and lower order address. So higher address, suppose this 10, so this 10 will be here, 10H. Always you have to write H, because if you write 10, that can be taken as a decimal. But this is your 00H. So this 00H will be there. So in this particular, suppose the memory location, starting memory location is 00H. So in this memory location, suppose the data is, whenever you are placing this memory location, suppose this the content of HL register pair, suppose 2050H, in this 2050H memory locations, the content of 2050H memory locations is something that is suppose 07H. So that data byte will be read from memory, because this is my memory. So in this memory location 100H, whenever we are going to write, so for this particular location 2050H, so this 205007H data byte will be moved to, is copied to this data byte, and this is also going to happen in this T2 to T3. This here ALE again, I am saying that ALE will be enabled to distinguish the higher order address means to distinguish the lower order address and data byte from the complex multiplexed bus. So ALE will be enabled only on the T1 state, and then it goes to low. So RD, because we are doing the memory read operations, so obviously read operations we are going to do. So here we are taking 1, that means if we provide 1 bar equals to 0, so till now it will be, this is called low enabled signal. And only low enabled means whenever you are giving the low input, it will be enabled. So here the low input we are providing from, suppose this is my 1 and this is suppose 0 state, so obviously 1 to 0, so this 0 bar equals to 1, so that means from T2 T3, in between this T2 and T3 it goes to high. No write operations we are going to perform, so no write operations, so that means enable, it has been provided as high input, so input high equals to 1 bar equals to 0. If I provide 1 equals to, because this is my 1, so 1 bar equals to 0, so it will be not enabled. And again the status signal for this memory read operation, IOM bar equals to 0, S0 equals to 0, S1 equals to 1. So IOM bar equals to 0 and S0, S1, these are all are the status signal. Because of these memory read operations, so it will be enabled, low enabled, that is we are providing 0. And this S1, S0, S1, so this is the combination of this memory read operation. I hope it is clear for you to opcode fetch.